Well, greetings and welcome to 90 Notes. This video on constructing squares is going to be limited to the practice exercises, pages 50, 51, and 52. I think I'll do a separate one on the various square constructions. So let's just get to it, all right? See how you did in class. In case you missed, here it is. So I'm going to scroll over here. All right, our first question. Which of these statements is true? Now, what I've made for you, I've got a equilateral quadrilateral down here, and I've got one that's not equilateral. I'm going to say this guy's a parallelogram because it is. Watch what happens with this parallelogram as I move it over like this. Interesting. Then it becomes a rectangle. When those two circles become one, that becomes a rectangle. Now, by definition, a regular polygon is both equilateral and equiangular. So this guy, no dice, whether I'm talking about the parallelogram or the rectangle. Either way, that can't be. Now this rhombus is equilateral. And when I cross through right there, bingo, that rhombus is now inscribed in a circle. This rhombus is now equiangular, and that means that it is, well, it's equiangular and it's equilateral. This one is the only one of those four figures that's going to be regular. So let's see what we have here. Rectangles? No. Squares? Yes. Squares are regular polygons. You know, I'm going to flip back to that previous page. Oops, not that one, the summary. And we'll talk more about this. But these are various inscribed polygons that happen to be regular, from the triangle, square, pentagon, hexagon, all the way up to the decagon. But we'll come back to that another time. Okay, so again, this one is going to be only the square. You know, I suppose it's maybe a good time to mention this, but sorry about the interruption. In this case, a rhombus or a square is a rhombus, but a rhombus is not a square, because to be true, it has to be true all the time. This McGraw Hill hasn't made a lot of effort to go through the rigorous definitions, but I guess we'll learn by doing. So we'll come back to that. Oh my gosh. This one, I had to go with really small print. And they give you this silly diagram. The nerve of them. All right. Now, the whole question was explain why we needed to construct a circle in step E. That's this circle right here. Let's get rid of this thing over here. And let's actually construct it from scratch. Now, oops, I'm going to get rid of those captions. There's your AB. Start with points AB. Then it says construct a line. All right? We can easily do that with a straight edge. And now there is your perpendicular passing through a point on the line. There's your other perpendicular, in this case passing through B on the line. Now, here's something interesting. E says use a compass to construct a circle centered at A passing through B. I don't know what he's talking about because we've already got it. Now, it's true, this circle could have been of random size back here in this earlier step, but you know, for convenience, we used the circle centered at A passing through B. So you see, this was already done. This step E seems to be not required because of the way we happen to perform it. All right, let's keep going. Now we're going to label this intersection C. And then we're going to do this construction. Yikes. And that's going to give us point D, and that's going to give us the square. Now, if you wanted to zoom in on it so you could get a better look, those are the various construction marks you can see. A lot of unnecessary construction marks here. I mean, we had this, and honestly, with the two perpendiculars, that would have given us points C and D respectively. But for some reason, we were just following this particular construction. And I honestly cannot see a good reason. Well, the reason that we had to have the circle A passing through B was to transfer the distance to AC or CA. And therefore, we have an equilateral polygon, which happens to be a square. Kind of messy, I think. But there you go. That's a construction. That's what all those steps would look like. Next page. 51. Right. Wow. All right. Now we're going to construct. What's the next step to make a line point through C that's parallel? Well, if we construct an equilateral triangle with sides CD, I thought I worked these out. Well, here they are. Hang on. I just have to scoot that over. I mean, that's not helpful. How about B? Construct a line through B perpendicular to AB? Well, that's over there. And that's got nothing to do with what we're looking for. And again, the size of your first compass swing dictates the size of the other compass swings. How about C? Construct a segment with the same length AB with. I have no idea why you would do this. And somehow you'd have to transfer this distance over to here. And any point on this circle, if we connected that to C, would be the same length as AB. Doesn't seem like it makes much sense. The only thing that does make sense is constructing this. And this is the way this is the way that we were looking at one of the two ways to construct a parallel line. Constructing a perpendicular and then constructing another perpendicular. Two lines perpendicular to the same line in a plane, that's a qualifier. Those two lines are parallel. So the only thing that makes sense right there, bingo. Right? Yeah, I'm happy with that. Oh, let's keep going. 4. Oh, what is going on here? Jada wants to, well, first off, these circles are not centered on line L. And we're going to do this without the compass. We've done this so many times. We would swing a compass at and I'll just make sure it goes some other point. Right there, random arc. That generates 2 points. One here, one here. And we construct the two circles, and right there you can see that we have constructed a perpendicular line passing through C. Oh, okay, I guess I'll draw it. Let me get that line. So that was the mistake. Mistake was that these circles A and B that Jada drew don't even go through. They don't even, they're not even centered on the line L. So that's not going to work at all. Oh, yeah. How about this one? What is going on with Noah? First off, I got no idea what this segment's for. So we're just going to make the rays. Well, hang on. This is the angle BAC they're talking about. If you want to make this work, these circles may be the same size, but they're not the same distance from A. So you're missing the first arc. So these two are useless. And not only are they useless, I have no idea what this segment is for. So I'm going to make that dash just so you can see where it came from. And we're going to just do this construction good old-fashioned way. Now, I can swing an arc. Now, I could go through B, but I could just go through some random point. And let's put that thick. That generates an intersection here with an intersection here. And I'm going to swing the compass here to here. And there's our 1, 2, 3 swings. That's my intersection. And let me grab that ray tool. And that is my angle bisector. Easy squeezy. All right, so these are, I guess, those troubleshooting kind of problems. I guess they're kind of fun. Okay, let's keep this going. 52. Oh my gosh, we've done this so many times. But let's see. We know that every circle is congruent. We've talked about that. We've mentioned the transitive property. And you know, we know that each diameter is twice the circle, so therefore they're congruent as well. And the various equilateral triangles. Let's see, used equilateral triangle on the figure. Just one? We could draw so many. I mean, we could go like this. You know, more fun if we shade it. How about that? So we could go like this. 1, 2, 3. I'm going to construct triangle interior. Missed it. There's one. How about if we go from here? So I guess these are the review questions. So we've got the mama triangle, papa triangle, and next time we'll look at the little baby triangle. So here's another equilateral. Construct. Okay. And how about a little one? How about a wee one? And we can see that this figure is just full of them. And actually, we could put it on the inside of the figure, or heck, we'll put it on the outside of the figure. Or outside of this other large triangle. So there's another one right there. You have so many options. So many. So we've got one there. Up. We've got one here. We've got one here. And we've got one there. 3 different sizes, all equilateral. Oh, and by the way, different sizes. These figures are similar. And that is a concept that is important. Similar polygons. Well, their angles are congruent. Corresponding angles are congruent. In this case, all the angles are going to be 60 degrees. But the sizes are not necessarily congruent. So these triangles are similar. Oh, we got another one, don't we? Oh my goodness. This was actually fun. You know, so you got the random point A, B in a plane. Let's make it big just for fun. And if we said, let's cut that segment in half, we're really trying to make use of that perpendicular bisector definition. The first part is perpendicular. The second word there is bisector, to bisect, to divide into 2 congruent segments. So perpendicular bisector, let's get that. Oh, is that wrong one? Hang on. I want that line. There, that's the one I want. That's the tool I want. Going from there to there. Okay, that was fun. And here we can color code these. Or we just keep going. I'm now going to... Oh, no, it doesn't ask to do that. Dang. That's all we had to do. I thought we were looking at that problem where we kept on cutting in half and then in quarter. And well, okay, that's not that exciting. But perpendicular bisector gives you 2 things. It gives you a perpendicular line. And I'm going to try to put that right angle symbol in there for you. You know, I have to trick my little program to do it this way. But I should do this. I'm going to put in this right here. That symbol, those tick marks tell me that those 2 segments are congruent. And maybe if I label this point I want it to be M. I could say that M is the midpoint, or the point M bisects the segment AB, or the line, which could have a name, also bisects the segment AB. And I want to put a little right angle symbol in there, right here. 1, 2, 3. And there you have it, a perpendicular bisector. You know we're going to see that again and again and again. Well, I guess that's it. I guess we are finished. Well, thank you. Thanks for watching Ani Notes, and see you in class.